Hello! Welcome once again to Improper online math class. In this video, we are going to discuss the topic integration by partial fractions. Kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. Now, integration is just the converse of differentiation. For proper understanding of what we are going to do today, go back and read the basics of integration. It will help you to master very well what we are doing here today. Okay, now when you experience fractional integrals like this, it's mostly we mostly adopt integration by partial fraction to deal with functions like this. So if you are given the integral of 4x minus 5 over x plus 1 into x minus 2 dx, and the second one to integrate. It's not so easy integrating this without employing the work of partial fractions. Now, before I go deep into this integral, you need to know what we mean by a partial fraction. Take for instance, if I have two smaller fractions, like 1 over x plus 2, and let's say 2 over x plus 3, for instance, these are two fractions on their own. If I try to add these two fractions together, I'll find out that their LCM is x plus 2 into x plus 3. That's their LCM, their product is their LCM. Now, this divide this means that x plus 2 cancels out x plus 2, leaving us with x plus 3. X plus 3 with times 1, we still get x plus 3. Plus x plus 3 divide this term here, or expression, we are left with x plus 2. So x plus 2 is multiplying 2, so we have 2 into x plus 2. Coming down, we have x plus 3 plus 2 times x is 2x, 2 times 2 is 4 over x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 will give us 6. Collecting like terms, we shall have that x plus 2x is 3x plus 3 plus 4 is 7 over x squared plus 3 plus 2 is 5x plus 6. Now, these two fractions here, let's say fraction A and fraction B, combine together to form a single fraction. So these two fractions A and B are called the partial fraction of this whole fraction here. Because if I split this fraction into two by process of partial fraction, I will get these two individual fractions. So it is easy to combine two smaller fractions to get the whole, but the process of breaking them down into this constituent part means splitting them into their partial fraction, and that is the logic we are going to employ in finding this kind of integrals. Okay, so let's go back to this integration, since you've learned what we meant by partial fractions. Okay, so let's begin with the first question, which is the integral of 4x minus 5 into x plus 1 into x plus 2. We can say, let's 4x minus 5 over x plus 1 into x minus 2 dx be equivalent to the integral of a over x plus 1 plus b over x minus 2 dx. Okay, this a and b are those two values that we need to place there to make these two fractions become the partial fraction of this whole fraction. So we need to split this into two parts. Okay, now let us try finding the LCM of these two fractions here. So let us remove their integral for the meantime. The LCM of the left hand side is still x plus 1 into x minus 2. This divide this, x plus 1 will be cancelled, x plus 1 remaining x minus 2. Multiplying a, we have a into x minus 2 plus x minus 2 divided x minus 2 we are left with x plus 1 multiplying b. So have b into x plus 1 equals 4x minus 5 over x plus 1 into x minus 2. Now this value and this value are the same. They can cancel out each other. So I can have that this and this are equivalent. Hence, a into x minus 2 plus b into x plus 1 equals 4x minus 5. Our target here is to get the values of a and b, which we need to fix here to get the partial fraction of this whole fraction here. Now, we cannot look for a and b at the same time. Therefore, if I want to get b first, I need to kill a. I need a to be equivalent to 0 so that I can get b. You see that if I plug in 2 for the value of x here, I'll have 2 minus 2, which is 0. And when 0 times a, I will get 0. So therefore, to get b, I will say let x be equal to 0, equal to 2. The essence of doing this is to make a to reduce to 0. So we shall have a into 2 minus 2 plus b into 2 plus 1 equal to 4 into 2 minus 5. 2 minus 2 is 0 and 0 times a is 0 plus 2 plus 1 is 3. 3 times b is 3b equals 4 times 2 is 8. 8 minus 5 is 3. So this 0 here is nothing. It's insignificant. So I will divide both sides by 3. B is not equal to 1 because 3 divided by 3 is 1. I've got b. Now let's get a. If I want to get a, I will set b to be minus 1 because minus 1 plus 1 will give me 0. So that b will go. So I can say let x be minus 1. So I have a into minus 1 minus 2 plus b into minus 1 plus 1 equals 4 into minus 1 minus 5. This is now minus 3 times a. I have minus 3a. This is now 0. So it has gone. Equals 4 times 1 is minus 4. Minus 4 minus 5 is minus 9. So I will divide by minus 3 to get the value of a. So a is giving me 3 because minus we cancel minus. Now I've got the value of a. So let's continue from at this place. So the whole integral we need will now be integral of a. What is a? My a is 1. My a is 3. So I'll use 3 in place of a. So I have 3 over x plus 1. I'm replacing a with 3 because I got the value of a here as 3. Okay? Then plus b. My b is 1. So I have 1 over x minus 2 dx. This is now what I'm integrating this time around. So the whole function has been reduced into this level. So this can now be written as the integral of 3 dot 1 over x plus 1 dx plus this and these are the same because 3 times 1 give me back my 3 plus 1 over x minus 2 dx. Whenever you integrate a function like this, it turns to ln x, okay, or the ln of the natural logarithm of it, 1 over, provided it's 1 over a term like this. So that's why I said you go and learn the basic integrals if you want to succeed here. So the answer here will now be 3. This is just ln x plus 1 plus this is just ln x minus 2 plus the constant of integration. So this is just the answer to this number 1 question, integral. So let's take the second question. Let's take the second question. So in number 2, we have the integral of 2x cubed minus 2x squared minus 2x minus 7 over x squared minus x minus 2 dx. This is also a partial fraction, but you've got to be careful. You'll find out that the term at the denominator is smaller in degree than the term in the numerator. The power here is 3, while this power here is 2. So this value here cannot carry this value. So you need to suspect an improper fraction. And whenever there is improper fraction, you have to employ polynomial division for you to be able to reduce it accordingly. So we need to divide this. Okay? So let's see how we divide. I have to divide 2x power of 3 minus 2x squared minus 2x minus 7 by x squared minus x minus 2. So as we are dividing, take only the two highest degrees in both expressions. So here I'm dividing this by this only. I don't touch any other thing. So I will say 2x power of 3 divided by x squared. This cancels out. I'm having just 2x. So I'll write 2x here. 2x times x squared will give me 2x cubed. 2x times this minus x will give me minus 2x squared. 2x times minus 2 will give me minus 4x. Okay? Then I subtract. The same way you do with your long division. This has subtracted this. This has killed this. Then minus 2 minus minus 2 is something as minus 2. Sorry, minus 2 minus minus 4 is the same thing as minus 2 plus 4, which is just 2x. Then I'll bring down minus 7. Now, I can no longer go further in this division because the degree of my divisor is bigger than the degree of my dividend. So, the power here is bigger than this power. I cannot go further to divide. Therefore, the whole number I got becomes 2x. Hence, we can write that the integral of 2x to the power of 3 minus 2x squared minus 2x minus 7 over x squared minus x minus 2 dx is equivalent to the integral of the whole number is 2x plus the remainder is 2x minus 7 all over x squared minus x minus 2. Remember, when you divide 9 by 2, for instance, you will get 4, remainder 1. We normally call it 4 whole number. So look at my whole number, 2x plus remainder 1 all over 2 plus my remainder is 2x minus 7 over 2. 2 is the number I'm using to divide, which is x squared minus x minus 2. Okay? So that's what I've just done here. The x. Okay, so now we are going to integrate this. But this is also another partial fraction. We need to split this into partial fraction because it's still not in order. So let's split this alone. When you have, let us leave the whole function for now and concentrate on this. When you have 2x minus 7 over x squared minus x minus 2, you can call it 2x minus 7 over, factorizing this, two numbers which are times we get minus 2. If you add, we get minus 1 should be minus 2 and 1, because minus 2 times 1 is minus 2 and minus 2 plus 1 is minus 1. So have x minus 2 x plus 1. So let us split it into partial fraction. Let's assume it is something as a over x minus 2 plus b over x plus 1. Okay, so now 2x minus 7 over x minus 2 into x minus 1 equals the LCM of these two fractions are something x minus 2 into x plus 1. X minus 2 divide this, we are left with x plus 1 times in a, so we have a into x plus 1 plus this divide this, we are left with x minus 2 times in b, b into x minus 2. Okay, this and this are equivalent, they kill each other, so we have that this is equal to this. So a into x plus 1 plus b into x minus 2 equals 2x minus 7. Okay, now if we want to kill a, we set x as minus 1, so that minus 1 plus 1 will give us 0. So let x becomes minus 1. We now have a bracket minus 1 plus 1 plus b bracket minus 1 minus 2 equals 2 bracket minus 1 minus 7. Okay, at the end of the day, minus 1 plus 1 is 0. So 0 times a is 0. A has gone. Minus 1 minus 2 is minus 3. Minus 3 times b is minus 3b equals 2 times minus 1 is minus 2. Minus 2 minus 7 is minus 9. Dividing both sides by minus 3. So have that b is equal to 3. Now let's get a. If I want to get a, I will set x as 2. So I have a into 2 plus 1. I'm setting x as 2. So let x is 2 plus b into 2 minus 2 equals 2 bracket 2 minus 7. 2 plus 1 is 3. 3 times a is 3a. This is 0. 2 minus 3 is 0. So this has gone. Equals 2 times 2 is 4. 4 minus 7 is minus 3. Dividing by 3. So have that a is minus 1. So we can now fix them here. Then we now have this as integral of 2x plus, seeing this whole fraction, the fraction is now a over this plus b over that. And our a is minus 1. Okay, so it's not funny, it's not always better to write negative number before the positive. So let me write b first before a. So my b is 3 over x plus 1 plus a is minus 1. So here I change this to minus 1 over x minus 2. Then we integrate with respect to x. If I integrate 2x, I have 2x. The power is just like 1 plus 1 over 1 plus 1 plus this one, as usual, I will turn to 3 ln natural logarithm of x plus 1 minus natural logarithm of x minus 2 plus the constant of integration. So this is now equivalent to 2x squared over 2 plus 3 ln x plus 1 minus logarithm of x minus 2 plus c. 2 cancels out. So finally, this integral turns to x squared plus 3 log x, or ln x plus 1 minus ln x minus 2, then plus c. Okay, so you've now seen that it's not a big deal to integrate by partial fraction. At this point, we are coming to the expiration of this episode. Kindly hit the red button to subscribe to my channel if you like what you've watched. Thank you so much.
Hey there. Subscribe to my channel. And also press this bell icon.